Hello, my name is Nathalia Rus. I am co-founder and engineer at Custodian. Today my talk is Atomic Design with TypeScript, a match made in heaven. So first of all, I would like very quickly to show you how I came across Atomic Design and why I believe that it may be a real game changer for you as well. So I've had 3 phases in my coding journey. Each of them brought a set of new challenges and also game changers. So first phase, I was hacking around. The game changer was when I understood that the trick is to read the docs, and I came across the problem that the hackathon world is quite different to the real world. It's really different to build something hacky and like a prototype in a week compared to building something everlasting that is maintainable and wise. And that problem became apparent when I had to start building the platform from scratch at Custodian, which is kind of a complex platform with a lot of moving parts. And it's an ambitious company. It's not just, it was not just making a prototype for 3 months. 2 game changers during that phase. 1, I transitioned from JavaScript to TypeScript, and there is no way back. 2, I really had to learn how to stop myself from the urge of coding and just think twice before I do anything. For example, planning things on Lucidchart and FigJam, etc. I had a whole new problem, which was the contrary of what I had when I was hacking around, which was I ended up with mega efficient code. I was abstracting way too early, no flexibility whatsoever. I was coding workarounds, which defeated the whole point of the game changers I mentioned. For example, you're in a pretty bad place when you type any as a type everywhere. I therefore understood that what I was actually trying to strive for was the graal of what I call REF. REF is readability, efficiency, flexibility. All of these 3 things have very fine lines between each other and pros and cons. And so I was looking for workflows and architecture that was doing 3 things. 1, making my code easy to read at the end. Good code is simple code. 2, that keeps a lower developer overhead. What I mean by that is, if I have to go back to my code base and change things or add things, it should be very simple. It shouldn't be something which I dread. When I go there, even if I don't remember what I've done, it should be easy to understand what's going on. 3, allows for flexible and consistent changes at once. Flexibility and consistency are these 2 things where they can coexist. It's just difficult to get to that place where they coexist. Little did I know that actually what would make REF achievable was not a workflow or architecture textbooks, but rather a new mental model. That new mental model ended up being, for me, Atomic Design. The way I came across that, my mentor, gave me advice. He said, don't try to reinvent the wheel. A lot of people have come with this problem before. Go build on the shoulders of giants. And I saw that Airbnb mostly, which I really admire, they've used that quite heavily. And so I was there like, okay, I have to take this seriously. It's kind of a big deal. And yes, at first I had thought that a design system would only be relevant to designers or marketing, branding, etc. But actually, when you look at the definition, you can already start thinking in terms of code. A design system is a complete set of standards intended to manage design at scale using reusable components and buttons, which is what I've implemented. And now I promise you, I don't have problems with code base. There's always room for improvement. But really now my focus is to train, communicate between developers, making sure that as the team grows, the best practices keep being there and that people really understand the philosophy and embrace it. So 1, what is Atomic Design specifically and why is TypeScript such a good match? We'll show a lot of code through them. But if there is one thing that you have to remember in terms of what is Atomic Design, what is its core concepts, is this thing. Do not think in terms of pages anymore. That's in the past. The new way of thinking now is thinking in terms of systems. You have to spot patterns first. You notice the smallest bits first. You combine the bits into progressively larger bits up until you end up with a page. So next time you go on an app or any kind of digital platform, try really to adopt this way of thinking and you'll see things completely differently. I would also encourage you to read any content from Brad Frost, which is the person who basically invented Atomic Design as a concept and really made content around it and researched it quite deeply. Really good content. So I have 2 exercises for you. I won't dive on that too much, but please do that after the conference. 1, have a look at the Airbnb storybook because they have thousands and hundreds of small things which can kind of look chaotic at first and overwhelming. They made such good work at making sense out of it, making a unified system, which is super simple with hierarchies that make sense and everything fits seamlessly together, even if, it could be so chaotic. There are so many small bits. And, their way of like putting things together is really cool. And you will see their app differently. You won't think in terms of pages anymore, I promise you. Another good exercise would be to check Anti-Design's source code. The source code of Anti-Design has been instrumental for me. Again, they are using TypeScript. Again, like they are basically a UI library where everything looks so consistent and they have so much moving pieces and so much optionalities, and seeing how they've coded it in with best practices was really good. Now, let's go through Musace, which is an example project I've made with Atomic Design in TypeScript and React, but I don't put much emphasis on React because it doesn't matter which framework you're using or which library you're using. It's going to be the same concept, really. So when I'm going through the app, please try to not look at pages and the text. Everything is a placeholder, I'm sorry. But yeah, try to see the patterns I mentioned. Try to understand where I'm coming from. So I'm going to answer a bunch of questions, and the whole point of the app is to recommend you cultural artworks that you may like. So if you're not a cultured person, that can kind of give you an idea of what you've been missing on in culture. So let's go. Okay, this looks the same, this looks the same, this looks the same, this looks like it's the only kind of changing variable already. You have the ratings, another rating, another type. And you have, this time you have an asset, okay? This looks similar than before. This looks very similar to just have this image. Here, same, we've seen this, just the image. Submit. Now it's meant to look for recommendations for me. And here you have the main section with cards, with paintings, classical literature. Yeah, I haven't put images to books because it would be literally judging the book by its cover. You could go inside of one. Cool. Okay. Nice. Okay, hopefully you spotted patterns, not pages already. The cards are a really good start because they are across different sections, and there are many constants, many things exactly are the same. There's one changing variable, which is basically the type of asset, whether it's an image, whether it's a Spotify embed. The rest, as you can see on this slide, the same. Constant, the section header, the wrapper UI, the tags row, the row of information, the title type, everything is the same. Same for questionnaire. You can see how across the different pages, it's all the same page really. It's like, you don't even think in terms of that anymore. You just see how the sections are made. The constants are again there. Two variables, one with or without assets. Already it's kind of coded in your head. You have, there's a Boolean there, and there's a form type. Again, hint for the instrumental use of TypeScript. You have certain number of form types that you can have, and it needs to match one of them. And you have, for example, rating or radio or checkboxes. So hopefully now you understand how the design language is actually really relevant for you. This slide actually has been made for pointing to the fact that atomic design does not mean dry. Don't repeat yourself. A lot of people online, when they try to implement atomic design, were kind of doing the mistakes that I was doing in my phase 2, which is don't repeat yourself. And then they end up having mega systems which take it too far, and it's impossible to kind of make changes or to make it legible. So don't be too harsh on yourself with repeating yourself. Sometimes repeating yourself doesn't have to be bad. And atomic design can point to don't repeat yourself because we put a lot of emphasis on what is reusable, but actually there is a fine line, which we'll see. So now let's go through the folder structure, shall we? You have to think in terms of, your app is like a breathing system. It has atoms, molecules, organisms, it's like a biological allegory. And, I've kept the exact same jargon in my folders because then in my head, it forces me to think of it, Atoms is where all the smallest bits are, extremely reusable. 90% of the styling happens there. Even more than 90%, I think. What the molecules are for is that it assembles a group of atoms with minimal styling. The styling that you'll find there is usually paddings or flex layouts. What is interesting is that a lot of criticism of atomic design is that you end up with apps which look kind of molecular and atomic and kind of robotic. I think that this is in the molecules where you can really have the opportunity to try to glue the atoms together in a way that feels natural. This is where you have the styling, where the atoms shouldn't be just like put dry on the page, but they should really like be put nicely together, you know? So I do believe that if your concern is that your app is going to look too robotic, you can do some styling work in the molecule when you put things together. I would say this is kind of the key secret, really. Organisms, by the way, just so you know, a lot of people do it differently. So a lot of people understand what organisms are and what templates are differently according to their needs. That's completely fine. This is kind of my version of atomic design, which worked well for any app I've made. But if you come across something better, or if you don't like any of this, that's completely fine. As long as you adopt the whole mentality of atomic design and the concept, you can do it as your sauce. So organisms is what I call the logic layer. There is no styling. Its components decide of the correct generation of UI, so basically what molecules to show, the constants, and what functionality to add based on the data it receives. It's really kind of the brain of your front end. Outside of Redux and whatever, this is where, you know, the UI logic kind of comes into place. Now, if you look at the page is literally just there to pass down the relevant data to the relevant organism, nothing else. Again, there's not much styling at all, if any. Templates encapsulates a page, transcends a page. This is where you would have, for example, the main layouts or stuff like, you know, transitions between pages, etc. These, again, this contains styling, not much. It kind of is just to kind of wrap the children. Now, let's see at examples of, you know, folder structures, and also like example of what's inside of it. So if I look in my atoms, you know, if you want to have that as an inspiration for your own projects, usually what you will have in the atoms is pretty standardized. You will have the buttons, you will have icons, you will have images, you will have skeleton, you will have typography, folder, etc. Something which I'd like to say here is that the icon file, this file that you see here, I've taken this direct inspiration from Andy Design Codebase. Their source code is really cool, and they have a huge file called icon where they have all of their icons in it, and they have a lot of icons. And at first I was there like, gosh, this file is huge, I would get lost. But actually no, you don't get lost, because it's the same thing. You declare your icon, you just say like it's a possibility, it's there, you put your asset here, and you don't really need to code on that file. That file is literally there so they can be reused across all the platform in a centralized way. And this is where, you know, if you have new engineers coming in or designers or whatever, like they know that these are the tools that you have, these are the icons that you have at your disposition currently in the code base. And if you want to make change, it's all in one place. So definitely try to be strict with yourself. If at some point you need to import an icon, don't get just the assets directly and put the image. Really force yourself to have the discipline to, every time you import a new icon, you declare it in the icon file, you add it to the type, and you use the actual icon component to render it. I promise you, it's worth it. It makes it super cool in the long term, and also makes teamwork super easy and clarity over what's going on. Yes, paragraph is another good example of something you'd find in the Atom folder. Now, you can already see how I'm embedding my code with TypeScript quite a lot. I'm leveraging it a lot. So where TypeScript is really cool, more on this later, but is to give you flexibility in a way that doesn't end up like a huge monster. So this, without TypeScript, with just JavaScript, would be kind of a suicide mission. There are so many different things that need to be, you know, perfectly written without any misspelling, or, you know, everything is so centralized to a specific way of writing the ID, etc., which you pass down. And TypeScript really kind of gives this structure, gives you this kind of bug-proof way of doing things. So for example, here, you know, I pass a lot of different checks and conditions. So for example, you know, if If it is of the type radio, if it is of the type checkbox, you do something different. Same for the typography option. This is how you have flexibility while reusability and consistency. This is kind of the growl, like, balance that I was talking before. I do believe it's easy to read. I do believe I understand what's going on. And I do believe, if I want to make changes, I can. I just have to pass down different typography options. If I don't want to pass changes, that's fine. These are optional, and it's easy to read. So it's reusable, flexible at the same time, and legible. So that was kind of what I was looking for. Hopefully you kind of see it as well. Cool. Now another example is now into the molecules. You can see you can notice how I'm basically grouping atoms, and I'm adding sometimes a bit of styling such as padding and other UI checks to make it fit all nicely. But that's it really. So for example, the kind of files you would have in molecules where you can see you have form elements, rows, instead of form elements, I have checkbox group, everything is group, these kind of things. Now, organism. You have stuff like form maker, item body maker, list maker, view manager. You can already see in the naming that something is a bit different there. It's a maker. It doesn't just show, it kind of makes something. Okay, I avoided the term generate because some people think of generative functions, etc. But it basically kind of generates something, to be fair. What it does is, this is where you have the logic, the kind of brain of your UI, where you're like, okay, those things are constant. I have one variable which is changing. What do I do of this variable which is changing? Those things, the constants here, they're not styled components directly made inside of the organism. They are imported molecules. Okay, and the changing variable, do you remember that we mentioned before? So, like whether it was showing, for example, a Spotify embed versus an image versus nothing. This is where it makes sense of it. You pass down the item, and based on the category that it pertains, it will show different things. That way, I believe, again, it's easy to read, easy to understand what's going on. If you wanted to make change, you could. This is where don't repeat yourself is a good example. I could have made this, and if I was in my phase 2 still, I definitely would have been guilty of trying to refactor this again so that I don't have to repeat myself when I have like a full width image mobile, for example, component. I would have made so that sculptures and paintings would go together and like show this. This is where don't repeat yourself comes into place. If in the future I want to change the UI of each category to do something a bit fancier, as I move along and I grow the app, then, I just have to change here what I'm returning, what I'm showing. It's, like repeating yourself sometimes is not bad, as long as you know why and as long as, it's thoughtful. Okay. Now, another example of organisms so that you have it in mind. Again, constants. This is inside of the questionnaire page, and you can see how really it's exactly as I said. Basically, you have the constants, which are the molecules, same, and then changing variable, and depending on what the variable is, you show different things. The templates, hopefully templates kind of make sense by just looking at the structure of the folder. You have transitions, menu, containers, device, etc. Nothing too fancy. The code is pretty simple. It's usually, like the wrappers which are around your children, and that can be like animations, that can be scrolling top, that can be the media query that you want to pass, only desktop wrapper, for example, would be if I don't want to show like the iPads, which could be desktop-like, stuff like that. How TypeScript is a no-brainer for atomic design. So let me show you, I think it's going to be, the code is going to be quite telling. Let me show you, for example, how I built my questionnaire. So here on my page level, you can see there is no styling. I'm using template, and here I'm using, the relevant organism, and I'm passing through the data. I'm not doing anything else. The organism itself kind of does the logic, like it creates the functions to understand the navigation, etc. It also understands, what to render in terms of form body, as said. So you have the molecules here, and then you have this. Now, the beauty of TypeScript is that here I'm like form type is of types form type. Okay, I'm not using enum. I'm using, I like to use that. It's also advised inside of the documentation for performance reasons, but also the fact that this is basically an object, which is JavaScript. And basically you keep the nice bits of JavaScript and you superpower it with the type assertion, like union types and such other things. So for example, form type here, I'm like, okay, I'm creating a type where I can pass in something which is of either of these properties. And this is really handy. So then when I come here, I'm like, all right, well, if I didn't have like TypeScript and I want to say, okay, I think this is where you have radios. Well, this would not work. It would throw an error, say, this is not comparable to form type. It would tell you. So you don't have to hard code anything or remember things. Trust me, when you have a lot of these systems in place, you really don't want to have to like switch files and whatever to remember exactly how you spelled an ID. Like, it's not how you want to do it. And also, yeah, this kind of suggestions is everything. It's really, really cool. It saves lives. So I don't really like to have like hard-coded strings. I quite like to use like the JavaScript form type dot, because then, you know, I can change what this actually means behind in one place if ever need be. Like, for example, if I want to have from uppercase to something else for some reason, I would be able to. So it kind of keeps things not too hard-coded. Again, radio group, this is your molecule. Nice, which itself, again, like the form container, which is a template, because I'm using this in all of the forms as a form container. It's very, very consistent. And here I'm using the form components, which is the atom radio single. And here it's exactly the same story. How cool. It's cool, right? Nice. So you can see how TypeScript is a no-brainer. Atomic design ensures that everyone, users and teams, are all on the same page, visually, intuitively, and in the mindset. But it's still pretty abstract, right? What TypeScript does is it basically ensures that atomic design is implemented without errors. You know, it looks at on the ground, how do you do it with atomic design to make it maintainable and doable? It makes sure that the engineers are all on the same page. To an even deeper level, everything needs to be clearly defined and expected. It's like documenting the whole atomic design hierarchy and components. It's really cool, very powerful, especially when you work in teams. With TypeScript, you can leverage the reusability and systematic approach to take it to the next level. You explicitly define once the relationships in your types, what comes in and out of your components, and you can be strict, making your atoms, molecules, and organisms robust. You can make the system bug-proof and more collaborative by flagging up inconsistencies as your type, and also the relationships are clear to see, you know, the legibility that I mentioned before. Yeah, when you have something which is super reusable, legibility can become a problem. And with TypeScript IntelliSense, and you know, when you hover on things and you see things like this, makes such a difference. And you can correct suggestions while you type. Let's switch to code editor. Actually, we've already kind of seen this, so I think I will go back to this. Practical examples where TypeScript made a whole difference while implementing atomic design. Forms. Forms can be quite complex and they have their own needs. However, with atomic design, as we've seen, the forms really look alike in a lot of ways. And you realize this when you do the types. When you do the types for each form items, you realize what they have in common, and you realize the variables which is changing, you know, the one I mentioned. It's kind of exactly the same mindset and the same way of thinking that atomic design when you do your TypeScript types. You try to understand what is the same, what is different, what is optional, what is required. It's this thinking where, this systematic thinking where it's exactly the same as in atomic design. It's so compatible with how it works, you know, what you have to do to make it works. Defining types is a process that makes you realize the similarities, the constants, and the elements that change variables. You can visualize the components and hierarchies as you read through them. So, you know, I have an example of like the forms, again, you know, validations options. We haven't seen it in the code, but it's really cool. Like you can basically like generate validation schemas based off validation options that you put on the questionnaire, which is really powerful. And again, thanks to TypeScript, you basically have an idea of what you can put as a validation option. And if other engineers work after or before me, they can add to validation options. If they change something, they will see it that, you know, they were not meant to change it. And therefore, when someone pushes the code, I know that, you know, there may be mistakes, but at least I would see if there is something that goes wrong straight away, the code doesn't compile. And again, what we've seen, IntelliSense, suggestions, and flags, which save the day more than I can count. I would say TypeScript is not only super helpful for understanding the philosophy of atomic design to like a super deep level, but also it's all these little things that you take for granted when you type this TypeScript, that when you go back to JavaScript, you just realize, my God, how was I doing without it? It saves the day, not just for the logic standpoint, but also for the small nitty-gritty detail where you can just focus on the logic without worrying on the fact that you misspelled something or you can't remember something. When you have to hold like a lot of those systems at once in your head, like these things really do make a difference. So being explicit again, and this is where the dry component I made earlier, when you do types, just try to make sure that you don't take it to the novel, which is a bit too much. Make sure that you define explicitly, but not overly. Now, this is the end of the talk. I hope that you understood what atomic design is and how it can be relevant for you. I have a few readings which I'm really would like you to read if you're interested in this, and obviously feel free please to contact me at Jaeger's Code. I'm on social media, and yeah, thank you so much.